Hi, I'm Damaris Butters. I'm a first year PhD student here in the Department of Earth Sciences at Bristol. And I started my PhD in September 2017 and I finish in January 2021.
Fine.
As well as BHP, my project is also funded by NERC, which is the Research Council, and they provide opportunities for training and interdisciplinarity between universities in the UK. So the benefits of the training opportunities provided by NERC are that I'm able to go and use equipment elsewhere, such as in Cardiff, and I'm also able to attend courses like probe training courses or software courses that will be beneficial for my project. In my PhD, I'm developing a new technique which involves looking at zircon-hosted melt inclusions from porphyry systems, and I'm hoping to develop them into an exploration tool. Yeah. Okay. So a melt inclusion is a trapped portion of silicate melt that you find in minerals. So in zircons, they tend to be around 10 microns, so they're very small, and therefore we need to use specialist equipment to be able to analyse them. So the problem we have in porphyry systems is that most of the host rocks have been pervasively altered by acidic hydrothermal fluids. So often the last mineral remaining is zircon, which is why I'm hoping to use melt inclusions in zircons to access the primary porphyry melt compositions. So often we can't get a good idea of what composition of the magmas were originally, given the alteration by the fluids. So I'm hoping to use techniques to analyse not only the melt composition from melt inclusions, but also the volatile budgets of the primary magmas. So for my PhD project, I'm collecting lots of zircons from mine sites in Chile, and I'm also taking samples from volcanic deposits in Chile as well. And I'm going to be comparing the compositions of the melt inclusions between the two and how well they're preserved in the different suites. In order to extract zircons from my samples, I first take the whole rock sample down to the crushing room downstairs, and I put the sample through the jaw crusher, and this basically grinds the rock down into fine fragments. And then I take these fragments and I go and sieve them, and then I take that sample and I go through fluid separation, and then eventually you get a zircon separate, which is where all of the other minerals have been separated by flotation in the different density liquids. And then I go on to take these zircons and I put them in a petri dish, like you see here. So I'm currently in the MinSep lab, which is where we do our mineral separation. So I come in here to pick my zircons and look at them under the microscope. So if you look over here, this is just what I'm looking at right now, which is a bunch of zircons in a sample. And if I zoom in, you might be able to see some of the melt inclusions, which are these areas just here. And we then go on to take these samples and analyse them with microprobe techniques or the ion probe, so we can get an idea of the major element chemistry of the melt inclusions and also the volatile budgets. Yeah. Okay. So these tiny grains that you see in the petri dish here are actually zircons, but they're very, very small, so it takes a bit of time to be able to transfer them to a separate petri dish. So the kind of equipment I'm going to be using for my project is the electron microprobe. which is a machine that you can use to obtain major element chemistry from melt inclusions. And this will give us an idea of the composition of the magmas which form the porphyry deposits. I'm also going to be using a secondary ion mass spectrometer, which is a machine that you use to obtain trace element chemistry from the melt inclusions and also their volatile contents. So the interesting thing about using melt inclusions is that we can obtain an idea of what the volatile budgets of the porphyry systems were, but we can't obtain this from using the whole rock compositions. So if we know an idea of the volatile budgets of the systems, we can produce better models of volatile X solution from the magmas. So the collaboration with BHP has been really useful for me in being able to obtain rock samples from mine sites around Chile, which otherwise would have been really difficult to obtain. So the collaboration between BHP and our group at Bristol is that it's enabled me to be introduced to people in Australia. So I'm currently collaborating with a group of researchers at Perth. So it's great because we can share samples and do complementary studies on those samples. And also BHP provides extra finance for my project, so I'm able to go and use specialist equipment at other universities in order to analyse my melt inclusions. So as my project focuses on developing melt inclusions in zircon as an exploration tool, I'd like to go and do an internship with BHP in exploration so I can see how my project fits into the BHP workflow. And it will give me ideas on how I need to develop zircon and zircon-hosted melt inclusions as an exploration tool.